Okay, in this lesson, we're going to finish off looking at all the questions from tomorrow's number assessment. We saw quite a few types of questions on Friday. Maybe you remember these, and you have access to these on EduLink now. But in this lesson, we're going to look at the questions we didn't get to. So we'll start with these indices questions. Can you, for each of these, simplify and perhaps evaluate, which just means work out the value, work out what it's equal to? And remember, you have to do these without a calculator. So please pause the video for a couple of minutes and then unpause it, and I'll show you the answers. Okay, so this first one is a fractional indices where we have the number on the bottom of the fraction being the root and the number on the top being the power. So you did see a few of these on Friday, actually. Perhaps you remember that we have to do the square root of 16 and then we cube it. So that's going to be 4, that's the square root of 16. Then we cube 4, times it by itself 3 times, and we get 64. Now the second one, we didn't see one that looked like this on Friday, but actually it is exactly the same as the previous question. The order that you do the rooting or the power, in this case cubing it, doesn't actually matter. So this would be exactly the same thing as doing root 16 and then cubing it, either way. So in fact, it's exactly the same as the previous question. The third one has two terms in it. There's 36 and this y cubed. Now, when you're working with surds, you can split these two up into separate surds that are then multiplied together. So I'll show you what I mean. You can write it as root 36 multiplied by root y cubed. It's the same thing. Now, root 36, we can evaluate that, so that's just 6. And the square root of y cubed, well, we can't do what we did here because we don't have an actual value, but we could write this as a fractional power, which would be 3/2. So you can see that this kind of expression is the same thing really as this, which is the same thing as this. So we can simplify it like that. And the last one, in a similar way to the previous one, you can split it up, but this time it's a fifth root, not a square root. So still works the same way. We can put it as a fifth root of 32, and then separately that can be multiplied by the fifth root of 3 to the power of 10. Okay, now the fifth root of 32 is 2. 2 times 2 times 2 times 2 times 2 is 32. So that's going to be just 2. And then the fifth root of 3 to the power of 10, well, you could work out what 3 to the power of 10 was and then try and find its fifth root. But remember, this is without a calculator, so that's going to be pretty difficult. But if you remember what a fifth root would look like as an index, as a power, it would be a fraction, 1 out of 5. Then it makes this a little bit simpler. In fact, it would be 3 to the power of 10 all to the power of 1 over 5. Now, when you've got two powers in a bracket like this, you multiply them together. So that's going to be 10 times 1/5, which is going to be just 3 squared. So this turns out to be just 3 squared. You can then do 3 squared, which is 9, times 2, and you get 18 as the final answer. We'll now look at two more questions involving powers. These ones are simplifications of surds. In the first case, rationalizing a simple denominator. In the second case, doing the same thing. Let's move it so you can actually see that. The same thing, but then writing the final answer in this form here. Again, please pause this for a couple of minutes and try these, and then I'll show you the answer. So the first one, to rationalize a denominator, you get rid of the surd that is in the denominator, which in this case is going to be done by multiplying both the top and the bottom of the fraction by root 3. You can do that because if you multiply the top and the bottom by the same thing, it doesn't change the value, it just changes the way it looks, but the value will be the same. If you multiply root 3 by root 3, you get 3, because you are squaring a square root, so it undoes the square root. On the top, 1 times root 3 is just root 3, so you have this. You can have a surd on the top of a fraction, just not on the bottom. So that's that question complete. Very similar method in the second one here. Just write this out here. But we're going to multiply the top and the bottom by the root 2 that is currently in the denominator. Now in this case, when we multiply the top by root 2, we have to remember that there's really a bracket around there. So when we do this, it's like expanding a bracket with root 2 multiplying both the 10 and the root 18. On the bottom, it's going to be just 2, cancelling out the surd. Over here, we're doing root 2 times root 18. Two surds can multiply together to make, in this case, root 36. And then 10 times root 2 is just going to be 10 root 2. Remember, it's not root 10, so it doesn't multiply inside the surd. So it's going to be a 10 and a root 2. Root 36, of course, you'll notice is in fact 6. Can't really do anything with this 10 root 2. That's pretty close to the answer, but we're looking for it in this form. So we have to divide both the terms by the 2. So we'll do that in the final step. 6 divided by 2 is 3. And then we have 10 root 2 divided by 2. It's just a 10 that's going to get divided by 2 here, because you can't go inside the surd and divide that by 2 unless you're dividing by another surd. So here's the answer, 3 plus 5 root 2. Finish this video here because there's a time limit on the videos, but the next one we'll see a couple more surd questions like that.